angle bisectors. So before we get to the angle bisector theorem, first of all, let's review what an angle bisector is. So an angle bisector is a ray that cuts an angle in half. Okay, that's the most basic definition I can give you. So if we take a look at this and we have angle BAC, then our angle bisector would be AD, and it's going to cut it in half into two adjacent angles. Okay, so adjacent, remember, means touching. So now I know that angle BAD is congruent to angle DAC, because bisect means cuts in half, so these are now going to be equal, and they're also going to be adjacent because they're touching and sharing a ray. That's an angle bisector. Now, the angle bisector theorem is going to say, well, if a point lies on the angle bisector of an angle, so let's say, for example, point D lies on the angle bisector. I know it's an angle bisector because I've got those two little markings there. Then it is equidistant. Remember, that means equal distance from the two sides of the angle. So then I could say that BD is going to be congruent to CD. That's our angle bisector theorem. Also notice that when you do the distance to the sides, the shortest distance between 2 points is a straight line. So it has to hit here at a 90-degree angle. Because if we had one of them kind of going up this way and one of them maybe like just going straight this way, then they're not congruent. Okay, so it has to be the actual straight lines that hit the sides of the angle at the 90-degree. The converse of the angle bisector theorem. So remember, this kind of in my head means like opposite. So instead of knowing it's an angle bisector, therefore it's equal distance, well, we're going to go the other way. So if we know it's equal distance, then we can conclude that we're dealing with an angle bisector. So if a point is in the interior of an angle, okay, so here's the point, it's on the inside of this angle, and it is equidistant to the two sides of the angle. So now I know this and this are congruent. Then we know that it lies on the bisector of the angle. So knowing this, we could then conclude that this and this are congruent angles. Example 1, find each measure. So we want to find the measure of angle GFJ. So G to F to J means we're looking at this angle right in there. Well, I have from J to G is 7. I have from J to H is 7. So this is actually our converse. Okay, so if I know that the distance to the edges of the angle are congruent, then I do know that this is an angle bisector. And if this is an angle bisector, then if this is 42 degrees, then I know that's 42 degrees. So we know that it's 42 degrees. Example 2, find the measure of RS. So on this particular picture, we know by those markings that SQ is an angle bisector. So if it's an angle bisector, then this point from S to P is going to be congruent from S to R. So we can set up that 6x minus 5 equals 5x. In order to solve this, I'm going to subtract 6x. Negative 5 equals negative x. Then I'm going to divide by negative 1. So 5 equals x. Now we have to find RS, which means we have to substitute our 5 back in here. Now if I look at this, I think it's way easier to substitute the 5 back in here. Because what's 5 times 5? 25. And if this is 25, then this is 25. So I know that RS is 25.